Hi everybody, in this video I'm going through the answers to the second diagnostic test. Now my formatting's gone a bit strange in this first question here, but the first question we're looking at is this sequence here, 98.6, 118.32, 141. Now it's meant to be 0.984. If you took that as 141 comma, then 984, then it's no sequence at all. But let's assume that you thought that that was just a typo and that was meant to be a decimal point. Well, in that case, what we say, if it's an arithmetic sequence, well then there's a common difference between the two terms and I'm adding some number d there and I'm adding the same number there. Well, is that true? If it is an arithmetic sequence, then 118 minus 98.6 should equal the same as 141.984. You can try that and it's just not true. So you can see that the first one is plus 19 point something and the second one is plus 23 point something, not arithmetic. The next thing I need to do is check if it's a geometric sequence. That means that times are there and times are there. There's a common ratio. If that's the case, then 118.32 divided by 98.6 should be the same as 141.984 divided by 118.32. We use our calculator and see that yes, that is the case. This is a geometric progression or a geometric sequence, and the common ratio is 1.2. We're multiplying by 1.2 to get from one term to the next. The second sequence that we've got, part B, is 59.3, 54.2, 49.1. First thing I'm checking is to see if it's arithmetic. If it is arithmetic, then we're adding D both times. So let's work out the difference between these terms. First time I'm going to say 54.2 minus 59.3, and that is negative 5.1. Let's see if it's the same thing this time when I say 49.1 minus 54.2. Type it in my calculator. And that there is negative 5.1. There is a common difference. The common difference is negative 5.1. It is an arithmetic sequence. Now, it's negative there because it's decreasing, okay? Each number is less than the previous. Okay, for question 2, I have got two sequences here, this one, and for each I've got to write the recursive function, formula for the general term. I've got to find term 12, sum of the first 10 terms. Okay, how are we going to do it? Let's look at the first one, 62, 51, 40. Now, what type of sequence is this? First thing we need to do is identify what type of sequence this is. I can see that going from here to here, I'm taking away 9, and coming from here to here, I am also taking away 9. So this is an arithmetic sequence, and the common difference is negative 9. Okay, let's go to the questions now. Part A asks me to find the recursive function. The recursive function goes like this. The next one in the sequence is the current one in the sequence plus the difference. So for this one here, the next one in the sequence equals the current one in the sequence, take away 9. That is all I need for the recursive function. Okay, part B. Write the formula for the general term. Well, the formula for a general term looks like this. Term n equals term 1 plus n minus 1 lots of the difference. So for this one, it looks like term n is equal to term 1, this one here, 62 plus n minus 1 lots of the difference, which is negative 9. Now I'm just going to rewrite that a bit better. Term n equals 62 minus 9 lots of n minus 1. Okay, part C. Part C asks us to find term 12. Well, I'm going to use this formula here. Term 12 equals 62 minus 9 lots of 12 minus 1, which is 11. 62 minus 9 times 11, which is equal to negative 37. Okay, final part of this. asks for the sum of the first 10 terms. So what does that formula look like? The sum of the first n terms is n over 2 lots of 2 term 1 plus n minus 1 d. So the sum of the first 10 terms is going to equal 10 over 2, 2 lots of term 1, 2 times 62, plus n minus 1, sum of the first 10 terms, 10 minus 1 is 9, lots of the difference, which is negative 9. And the answer to that is 215. So in terms of marking that question there, we have 1 mark for this, 1 mark for this, another mark there, and another mark there. Just 4 marks for that. Each question either right or wrong. Okay, for the next question, I've got the same thing just with a different sequence. This looks like a geometric sequence to me, so I'm going to see if I'm multiplying the same thing to get from there to there and there to there. So how am I going to do that? Let's say this one divided by that one, 36 divided by negative 108, and that gives me negative a third. So if I times by negative a third, I go from term 1 to term 2. And if I, what did we say next? Let's say negative 12 divided by 36. Negative 12 divided by 36, and that also gives me negative a third. So my R value here is negative a third. So it's negative, and having a negative R value means that I'm going to be bumping around between negative values in my sequence and positives, as you can see there. Also, because it's a third, each term is getting smaller in its value, 108, 36, 12. Okay, part A of the question asked me to find the recursive function. Recursive asks me for the next one in the sequence. Term n plus 1 is term n times r. And I asked myself, well, for this sequence here, what is r? R is negative a third. So term n times negative a third. That's the recursive function. Next, I'm after the formula, the general term. So remember, for all geometric sequences, term n is term 1 times r to the power of n minus 1, which in this case, term 1, that is negative 108, times r, which is negative a third, to the power of n minus 1. Now make sure that you put negative a third in brackets there. If you don't have brackets around the negative a third, then it is not correct. Okay, so far we've got 1 mark for that, 1 mark for that. I should say term n equals. Okay, so for part C, we have to find term 12. So I'm just going to use this function here. Term 12 is equal to negative 108 times negative 1/3 to the 12 minus 1. So negative 108 times negative a third to the power of 11, which is 4 over 6561, or you've got something like 6.10 times 10 to the negative 4. Another mark for that part of the question there. Okay, the final part of this one, we're after the sum of the first 10 terms. So we're going to go straight to our formula sheet, find that. So it's going to be negative 108, that's term 1, times negative a third to the power of n, which is 10, minus 1 over negative a third minus 1. Now I just type all of that into my calculator just like that, and it comes to negative 80.999. Another mark for that. Okay, question 3. In an arithmetic sequence, term 1 equals 91 and term 18 equals 69.3. Find the common difference and term 1. Okay, here's what I'm going to do. I'm going to do it in 2 ways. First, I'm going to go, that would be term 11, term 12, term 13, 14, 15, 16, 17, 18. Okay, this is an arithmetic sequence. That one there is 91, and this one here is 69.3. So because it's an arithmetic sequence, I know that there's a common difference between each term. So to get from that one to that one, I'm adding D. This one to this one, adding D again, adding D again, and again, and again, and again. So we have 91 plus 1, 2, 3, 4, 5, 6, 7. 7D is equal to 69.3. I can work out what the common difference here is, can't I? Well, I'm just going to solve that equation. I'm going to take 91 off both sides. Then I get 7D equals 69.3 minus 91, which is negative 21.7. Divide both sides by 7. That gives me D is equal to negative 3.1. Okay, so I found what D is. Now I need to find what term 1 is. Well, if I've got term 11 here, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, I can jump back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can say term 1 plus 10 lots of the difference gives me term 11, which is 91. So I know what the difference is. Term 1 plus 10 times negative 3.1 equals 91. Well, 10 times negative 3.1 is negative 31. Term 1 minus 31 equals 91. So then term 1 is going to equal 91 plus 31, which will be 122. Now, the question asked us find the common difference, which we said was negative 3.1, and term 1, which is 122. Now, that is one way of solving the problem. Now, it was a little bit mucky doing it that way, but so there's another way that we could think about. So let's start it all over again. This is the information we've got. Term 11 is 91, term 18 equals 69.3. I'm going to use the general form. So we've got term n equals term 1 plus n minus 1 lots of the difference. Now, I'm going to make two equations from that. I'm going to say term 11, so I've got is 91 is equal to term 1 plus, well, n minus 1. Well, this is term 11, so that's 11 minus 1, which is 10 lots of the difference. So I've made an equation using that. Next one, I've got term 18. This one's going to be at term 18, which is 69.3 is equal to term 1, don't know what that is, plus, well, term 18, n minus 1, so that's going to be 17 lots of the difference. Can you see here how I've made two simultaneous equations and I can just solve those? Now, how do I solve this pair here of simultaneous equations? Well, what I'm going to do, I'm actually going to do an elimination method. I'm going to say that first equation, take away the second one. I'm going to say 91, take away 69.3, which give me 21.7. Term 1, take away term 1 will give me 0. And 10D, take away 17D, will give me negative 7D. Solve that. D is going to equal 21.7 divided by negative 7, which will give me negative 3.1, which is what I had before. Now, I need to still find term 1, and I know that 91 equals term 1 plus 10D. That's just that equation there. I know what D is. 91 equals term 1 plus 10 lots of negative 3.1. 10 times negative 3.1 equals negative 31. 91 equals term 1 minus 31. What am I going to do now? Add 31 to both sides. And we'll get that term 1 is equal to 122, like we did before. Now, both of those methods are fine. For this one, I prefer this method because 11 and 18 are kind of far apart. It was a little bit annoying doing all that counting on. If I was just like, if I had term 11 and term 14, I'd definitely do it the other way because it's quite fast. But as the numbers get bigger, this method with simultaneous equations will always work. Okay, question 4. Term 4, we've got a geometric sequence. Term 4 is 62.5. So that's going to be term 4. So here's 1, 2, 3, 4, 5, 6, 7. Term 7 is 390.625. And I'm looking for R and term 1. Now, again, we've got some choices for this one. We can do a method sort of like I did before, or we can do some simultaneous equations. For this one, I'm going to go, it's a geometric sequence, so I'm multiplying by R to get there, by R again, and by R again. So now I have 62.5 times R times R times R, that means times R cubed, equals 390.625. Divide both sides by 62.5, 390.625 divided by 62.5 gives me 6.25. And then I'm after R is going to be the cubic root of 6.25. Now this is a horrible number, but yeah, something or other, let's just leave it like that. Now for this next one, we're to find the sum to infinity, if possible, of these sequences. Before we look at the sequences, let's just think about the sum to infinity and when it's possible. Two things. Firstly, it has to be a geometric sequence. If it's an arithmetic or anything else, forget it. The second requirement we need is that R, the magnitude of R, has to be smaller than 1. Now what that means here, if we've got a number line, our value for R needs to be between -1 and 1, somewhere in that range. Now, if it isn't, then we can't find the sum to infinity. So let's look here at the first one. We've got term 1 is 50 and R is -1/2. Well, -1/2 would be there. Is that in that range? Yes, it is. So yes, it's possible. And then how do we work that out? Well, the sum to infinity is equal to term 1 over R minus 1. So it's going to equal 50 over -1/2 minus 1. And you can just put that in your calculator like that, and it gives us 33 1/3. Let's look at the next one. Term 1 is 50 and D equals -2. What is D? D means that it's arithmetic. The sequence is arithmetic, so it's not possible to find the sum to infinity. Forget about that one. Next one, we've got term 1 is 50 and R is 0.8. Well, 0.8 is about there. Is that within the range? Yes, it is. So we just use our formula. The sum to infinity is term 1 over R minus 1, which is 250. 1 mark for each of those. Okay, this next one was done quite badly on the first diagnostic you had, so hopefully you've gone better this time. We've got to determine the possible values. Notice values, there might be more than one, of R and term 1, given that we've got our sequence, goes like this. X minus 4, 2x minus 3, and x minus 12, and these are geometric. Okay, so because it's a geometric sequence, we have this one divided by this one is equal to this one divided by this one. So let's just write that down. We've got 2x minus 3 over x minus 4 is equal to x minus 12 over 2x minus 3. Okay, we've just got to solve this now. So we're going to cross multiply. 2x minus 3 times 2x minus 3 is equal to x minus 4 lots of x minus 12. Expand this out. 4x squared minus 6x minus 6x plus 9 is equal to x squared minus 12x minus 4x plus 48. Next, we collect like terms. 4x squared minus 12x plus 9 equals x squared minus 16x plus 48. I'm going to take everything over to the left-hand side. So move this x here over. That's going to make 3x squared over here. Then what have I got next? Negative 12x here. And taking that over, so I'm going to add 16x to negative 12x, which will give me plus 4x. And then finally here I've got 9, and now it's going to be take away 48, which will give me minus 39 equals 0. I'm going to solve this quadratic. 3xx, 39 I'm thinking is 13 and 3. One of them's got to be negative. Let's try that one. That will be negative 9, multiply this side, negative 9x, and then plus 13x will give me 4x. That's what I want. So it factorizes to 3x plus 13, lots of x minus 3 is equal to 0. Solving this, 3x is going to equal negative 13, x is going to equal 3, x equals negative 13 on 3. Okay, so we've got two solutions here for what x is equal to. We've got x is negative 13 over 3 and x equals 3. I'm going to look at these two cases. So case 1. Case number 1, x is negative 13 over 3. So our terms in our sequence, x minus 4, 2x minus 3, x minus 12. Let's just put those values for x in. I'm just straight in my calculator here. Negative 13 over 3 minus 4. That gives me negative 25 over 3. 2x, negative 26 over 3 minus 3. Negative 35 over 3. This one, negative 13 over 3 minus 12. That would give me negative 49 over 3. Now I need to work out here, I've got term 1. Term 1 is negative 25 over 3. Now I need to work out r. Well, r is going to equal this one divided by this one. So negative 35 over 3 divided by negative 25 over 3. And that gives me 7 over 5. Now, I'm just going to do a check, make sure I'm right. I'm going to say that one divided by this one and see if that gives me the same answer. And it does give me the same answer, so I know that I'm right. Now, that is case 1. The second case we need to think about, case number 2, and that is if r is 3. And let's pop it in. 3 minus 4 is negative 1. 2x minus 3. 2 3s are 6, minus 3 is 3. And x minus 12, 3 minus 12 will give me negative 9. Okay, in this case, what am I multiplying by here? I'm multiplying by negative 3. So term 1, in this case, is equal to negative 1, and r is equal to negative 3. Okay, so they are our two options, and we need to have both of those options. Okay, this next one. Find the sum, we're after the sum of the first 10 terms of the arithmetic sequence that it begins with a plus 4, 3a minus 3, and 4a minus 4. Well, I don't need to worry about this yet, finding the sum of the first 10 terms. Firstly, I've got to find out what a is. Now, this is an arithmetic sequence, so I know that there is a common difference between terms. So getting from term 1 to term 2, I'm adding the same thing as I am getting from term 2 to term 3. So what I'm going to say, term 2, take away term 1, 3a minus 3, take away, make sure I use my brackets here, take away a plus 4, is the same as term 3, take away term 4. So let's write that down, 4a minus 4 minus bracket 3a minus 3. Next thing I'm going to do here is expand out and make sure I multiply that negative through. Minus 3a, now what's it going to be here? Minus times minus will be plus 3. Collect like terms on each side. Minus 4 plus 3, minus 1. Let's bring that a over there. 2a minus a is just a, and let's take that negative 7 over here. Negative 1 plus 7 will be 6, so I've got a equals 6. So that's a good start. What I need to do now is to just find my terms. I've got a plus 4 for the first one. A plus 4, 6 plus 4 is 10. 3a minus 3. 3 6s are 18. 18 minus 3 is 15. Then I've got 4a. 4 6s are 24. Minus 4 is 20. Is that an arithmetic sequence? Yes, it is. So we've got term 1 is 10. And the difference, I'm sure you can see there, is 5. Now, we are after the sum of the first 10 terms. So that equals, what are we doing? N over 2, 2 lots of term 1 plus n minus 1d. Sum of the first 10 terms, 10 over 2 gives 5. 2 lots of term 1, term 1's 10, it's going to be 20, plus n minus 1, 9, lots of the difference, which is 5. And that gives me 325. Okay, next one. In a particular geometric sequence, term 2 is negative 8, and the sum to infinity is 50 over 9. Find term 1 and r, given that r is negative. Okay, so we're probably going to have some options for r, and we need to choose the negative one. Okay, how am I going to do this? Let's write down some formulas first. The sum to infinity is equal to term 1 over 1 minus r. Now, I don't know what term 1 is, but we'll work that out. I do know what the sum to infinity is, and that is 50 over 9. That's going to equal term 1 over 1 minus r. We'll tuck that away until later. Now, I'm thinking to myself, wouldn't it be lovely if I knew what term 1 is? And I don't. But I do know what term 2 is. Term 2 is negative 8. Now, if I've got here term 1, term 2, term 3, etc., how do I go from term 1 to term 2? Well, I multiply by r. I multiply by r each time. So how would I go from term 2 back to term 1? Well, I divide by r. So I know that term 1 is going to equal term 2 divided by r. So term 1 is going to equal term 2, which is negative 8 divided by r. I can use that fact. I can pop that up into here. So I can say that 50 over 9 is equal to negative 8 over r divided by 1 minus r. Now that all looks very, very messy, but I can get rid of some of the fractions just by cross-multiplying. That times that equals that times that. So we have 50 lots of 1 minus r equals negative 8 over r times 9. Expand out. 50 minus 50r equals 9 8s are 72, negative 72 over r. Multiply both sides by r. R lots of 50 minus 50r equals negative 72. Multiply out again. Then if I bring all of this over to the right-hand side, I've got a quadratic that I can solve. So that's going to make 50r squared minus 50r minus 72 is equal to 0. Okay, I'm going to try the cross method here to solve this. 5r, 10r, 72, 9 times 8. Put the 9 there, the 8 here. 10r times 9, that's 90. 5 8s are 40. 90 minus 40 is 50. Okay, now I want to end up with negative 50r. So how do I put the negative there? Negative 90 plus 40 is negative 50. That's what I want. So I've got 5r minus 9 and 10r plus 8 is equal to 0. So here I have r equals 9 on 5. What is it? 10r plus 8 equals 0. 10r equals negative 8. R equals negative 8 over 10, which is negative 0.8. And there I've got two solutions. Now I'm told, here it is, R is negative. So this is the solution that I'm looking for. R is negative 0.8 and we're asked for term 1 and R. So, well, that's R, negative 0.8. And I know that term 1 is negative 8 over R. That's this one here. So it's negative 8 over negative 0.8. Negative 8 divided by negative 0.8, which will give me term 1 as 10. Okay, second last question. In a particular arithmetic sequence, term 1 is 17 and sum of the first 10 terms is negative 100. I've got to find term 3, but yeah, we'll leave that on pause, but we just need to find out about this sequence. It would be good to know the common difference. All I know is that sum to 10 is negative 100, so let's think about the sum formula. That is equal to n over 2. Remember, we're arithmetic here. Two lots of term 1 plus n minus 1d. Okay, so we know that when n is 10, sum of the first n terms, sum of the first 10 terms is negative 100. So let's use that. Negative 100 equals n on 2, that's 5. 2 lots of term 1, 2 lots of 17. 34 plus n minus 1, that's going to be 9 lots of the difference, 9d. Divide both sides by 5. Negative 20 is equal to 34 plus 9d. Take 34 off both sides, minus 24 minus 34. 9d then is equal to negative 54. D is equal to negative 54 divided by 9, which is negative 6. So we're after term 3, we can come back to that now. Term 1 is 17, term 2, term 3. Each time, what are we doing? We're taking away 6. So we've got 17, take away 6, and then take away 6 again will give us 5. So term 3 is equal to 5. Final question is about Betty and her crafting business. Betty makes necklaces and she sells them for $20 each, and bracelets, do bracelets in pink, bracelets, and she sells them for $10 each. Her bracelets and necklaces are very pretty and she sells everything that she makes. That's quite a business. On day 1, she is not fast at making either. So on day 1, she makes 3 bracelets. So I'm thinking that's going to be term 1 is 3, and this is about the bracelets. Put in bracelets here. Day 1, she makes 3 bracelets, and with necklaces. On day 1, she makes 1 necklace. She soon speeds up, however, and on each day she doubles the number of necklaces she makes. Now, if she's doubling necklaces, it's a doubling pattern, that's going to be a geometric sequence. And she doubles it, so R is going to equal 2. She doubles the number of necklaces she makes, and she makes 3 more bracelets than on the previous day. So this one here is arithmetic for bracelets, and it is a +3 pattern. Okay, find the total amount of money that she has made after the 10th day. So this is a sum of the sequences question. I want to find the total of number of bracelets that she has made after 10 days. So firstly, I'm going to ask the sum of 10 terms here. N over 2, 2 term 1 plus n minus 1 lots of the difference. Let's work that one out. 5 lots of 2 term 1 plus n minus 1, that's going to be 9 lots of 3. 27 plus 6, that's times 5. So totally, in those 10 days, she's made 165 bracelets. And she sells her bracelets for $10 each. So she has made $1,650 for bracelets. Hopefully her equipment didn't cost very much, because that's quite a nice haul with those bracelets. So let's think about the necklaces now. We're after the sum of the first 10 terms in this sequence here. Now, this is geometric. So how do we do that? We are going to do its term 1, lots of r to the power of n, that's going to be 10, and minus 1 over r minus 1. Okay, so 2 to the power of 10, take 1, okay, take 1 is 1023, divided by 2 take 1 is 1. 1023 necklaces. That's a pretty good number of necklaces to make. And she is charging $20 each for those. Okay, my goodness. She has made $20,460 for necklaces. Add those together and she's made a total of $22,110 in just 10 days. Wow. Okay, I hope you went well with those questions. Come and see me or Miss Delaney if you've got any questions.